Hey guys, today we're going to be building a board from Matrix Lab. It's the Noah V2. Let's do a quick unboxing to see what's inside the box. First, the accessories pack. It has all the extra screws, Bumpons, and connector cables. Next up, the PCB. The foam/silicone layer. The switch plate. And finally, the keyboard case. Noah is a 65% form factor top mount keyboard by Matrix Lab. The case is made of 6063 aluminum. I chose the navy blue color because I think it was the best color compared to other options during my purchase. We will take a look at the structure of the case in detail in the later part of the video. Let's see what's inside the accessories pack. 4 Bumpons were pre-installed on the case, and they have also included 6 more extra Bumpons. Next up, the USB-C Daughterboard. This small PCB here needs to be connected to the main PCB using the included connector cables. 2 connector cables are included in the accessories pack. One for the Daughterboard, the other for the LED strip for the case. This is the plastic LED diffuser for the LED strip. Final pack here contains the extra screws. Let's rearrange the screws and take a closer look. First up, 2 extra case screws. 2 screws for the LED strip. 2 screws for the Daughterboard. 2 extra SMT spacers. And 8 plate screws. Next up, let's unpack the switch plate. Matrix Lab only offers aluminum plate for this purchase. No other color options as well for the plate. As you can see, this is a full plate with a thickness of 1.5 mm. The finish on the plate is perfect, no scratches or scuffs can be found. Let's unpack the PCB. This PCB has per key RGB LED, and it is compatible with QMK. As much as I want a hot swap PCB, only solder version of the PCB is available. The top and the bottom part of the PCB needs to be snapped off before mounting onto the case. Because this is a solder version of the PCB, if you want it to be a hot swappable PCB, one of the ways is to solder MillMax sockets, and that is exactly what I'm going to do with this build. Next up, the foam/silicone layer. This piece of dampening layer actually feels like a mixture of rubber and silicone. Plastic peel on one side of the foam. And finally, the keyboard case. I have a pair of sweaty hands, so please excuse those fingerprints. Noah is the first 65% in the Able series. Matrix Lab stated that Noah retains the overall aesthetic and refinement of the Able series. Noah's design is trademarked by sharp outline, thick bezel, and chamfered edges. The designers uses multi-level mosaic structure on this side to achieve this layered, 3-dimensional visual effect. At the bottom of the board, it has this Noah wording alongside with the teal blue badge and a tiny little red square. The structure of the keyboard looks complicated, but it's actually not. Without further ado, let's take it apart. Because this keyboard has quite a number of different parts, let's break it down using the simple diagram here. First, the top case, the switch plate, the bottom case, decorative plate, decorative strip, the armor belt, the bottom badge, and finally the small little square here inside the letter A. We begin by unscrewing the 4 screws at the back that holds the bottom case. And the small PCB here is the LED strip. And next, to remove the armor belt, we need to unscrew 1 screw over here and the other over here. Two screws to remove the decorative strip and plate. And 2 screws to remove the LED strip. Let's take a closer look. This PCB here needs to be connected to the main PCB using the included connector cable. This side of the PCB shows 7 RGB LED. The purpose of the black sticker is to prevent the shine from leaking to other parts of the keyboard. This structure here sits on top of the LED strip, and it controls how the LED shines through to the top of the case. This structure consists of 3 different parts. You may also reconfigure this structure to your liking using the included LED diffuser. On the inside of the bottom case, the 3 screws here holds the bottom badge and the tiny red square. Not all the parts of the keyboard needs to be removed in order to build a fully functional keyboard, but it's always fun to take everything apart. With all that behind, let's start building the board. Before we start building the board, we need to test the PCB to see if it's working. And next is to test the LED strip. I will be soldering MillMax 7305 sockets onto this PCB to make it hot swappable. So what I like to do whenever I'm soldering MillMax sockets is to first mount the MillMax sockets onto the switch. Preferably on a 5-pin switch, because you want to make sure after mounting the switch onto the PCB that the switch is secured and stable when you flip it over to do the soldering. After mounting enough switches with MillMax sockets, it's time to mount the switch onto the PCB. Also, before soldering, do take note of the supported layout of the PCB, especially the backspace, shifts, basically the modifiers. After everything is confirmed, let's start soldering. After soldering is done, next is to remove all the switches, and this will leave all the soldered MillMax sockets in place. And we have successfully turned a solder version PCB to a hot swappable PCB. Next up is to install the stabilizers. I'm using Durock V2 stabilizers. For the layout that I chose, I only need a 2U stabilizer for the enter key and one more 7U stabilizer for the spacebar. Snapping off the extra part of the PCB. After installing the stabilizers, it's time to mount the switch. The foam layer goes between the plate and the PCB. I'll be mounting the C3 Tangerine switches in this video. Since the PCB is hot swappable, I can swap the switch out anytime to any switch I want. Once all the switches are mounted, it's time to put everything back together. And all that's left to do now is to mount the keycaps. With the yellow and blue color of the case, I had to go with GMK Nautilus. And finally, the build is done. And let's see how the RGB performs up next. First, let's talk about the LED strip on the top of the case. Basically, there are two different lighting modes on the LED strip. The first mode, as you can see, is the pure light effect mode. Multicolor and single color static and fading effect. Pretty much basic stuff here, nothing much to talk about. What I want to focus on is the second mode, the indicator mode. In the indicator mode, the first LED indicates if you have caps lock on. The second LED indicates if you have scroll lock on. The third LED indicates if you have num lock on. Fourth LED indicates if you are on layer 1. Fifth LED indicates if you are on layer 2. The sixth LED indicates if you are on layer 3. And the last LED indicates if you're on layer 4. Pretty cool. Next, I'm gonna show you the main PCB RGB effects. The main PCB has at least 36 different RGB effects. When I say at least, it's because I could not tell the difference between some lighting effects. That's why I don't count it as a separate lighting effect. If you're interested in the RGB effects, you may continue watching. If not, you may skip to the next chapter, which is the sound test. As you can see, the team from Matrix Lab put a lot of effort and attention to detail in designing keyboards. It's very impressive. Matrix Lab's keyboards always have this unique design that attracts me. Not to mention their interesting and vibrant colors on each component of the structure. It definitely makes their keyboard stand out in the world of custom keyboard. I have also included Matrix Lab's Discord server link in the description. In the server, they do giveaways from time to time. If you enjoy the adrenaline rush and the first come first serve sales, a purchase link will be announced randomly from time to time in the server as well. So guys, that's all for this video. Let me know what do you guys think about this build down in the comments. If you enjoyed this video, please like and subscribe if you want to see more.